Hello, today we're going to be doing a business application problem. This is the one from the recent quiz. So, pretty much in short, Tiger Woods is starting up a t-shirt business. The fixed cost is $14,000, costs $18 to make a t-shirt, and then the revenue from each t-shirt is $29. We need to find the cost function, revenue function, profit for 1,000 shirts, and then the number of shirts needed to break even, and then the amount of money needed to break even. So we'll start with the cost function. So we'll start by writing out the equation for cost function. And cost function
you're not making up a problem here. This using the one that's on that
is equal to mx plus b, and m is equal to the amount of money it costs to produce one t-shirt, and b is equal to the amount, the fixed cost, really. So, and then x is the number of shirts made. So you pretty much put that in there to figure out how many shirts you'll need to break even, how much cost you're going to have by things like that. So we're going to substitute all the values in. So now we get c of x is equal to 18x plus 14,000, because remember it costs $18 to make one shirt, and the fixed cost is 14,000. So now we'll simplify this, and we get, well, we don't even need to simplify it. So that is our cost function. Now then, we are going to look for the revenue function, which is r of x, and the revenue function is equal to mx, where m is going to equal the amount of revenue that each t-shirt is going to bring in, and x equals the number of t-shirts that you're selling. So once again, we will substitute values for that. So we've got the revenue for one t-shirt is $29. So we have Rx equals 29x. Now we want the profit. And the profit function is P of x is equal to R of x minus the C of x, or profit is equal to revenue minus the cost. So it's what you're bringing in minus what you still need to pay off. And so we find that after substituting the values in, profit is equal to R of x, so 29x, minus 18x plus 14,000. You got a problem, Stephen? No problems?
Cameraman?
No, cameraman, all good? Okay, well, we're now going to subtract these values so that we get 11x minus 14,000 is equal to the profit function. From here, we are going to find the profit for 1,000 shirts. So what we want to do is P of 1,000, because that's the number of shirts, right, is equal to 11 times 1,000 minus 14,000. Actually, this is the profit or loss. Could be either one. So then we will simplify this. So it is 11,000 minus 14,000 is equal to negative 3,000. So we can tell that from 1,000 shirts, there's going to be a negative $3,000 income. So they'll be in debt, which sucks for them. And now we're going to find the break-even point, or not quite the break-even point, but the number of shirts needed to break even. So to do that, we're going to take both of our function equations from up here, and we're going to go Rx equals 29x plus 0, because the B value for the revenue, there is one, but it's 0, and this is just for the sake of placeholding. And then the C of x, or the cost function, is equal to 18x plus 14,000. We are now going to eliminate the y value, or because these work as a y value as well. They're pretty much an equivalent for a y value. So we can eliminate them and through subtraction, and then we get 0 is equal to 11x minus 14,000. From there, we can go 14,000 is equal to 11x. Simplify it even more. We get x is equal to 14,000 over 11, which equals 1,272.7272. Goes on forever. But we want a definite number of shirts, so to break even, they will need to have 1273 shirts. So this is our x value, or the amount of shirts they need to break even. And now for the second part, we want to find the amount of money that they need to break even. So we'll go with something, pretty simple. So we'll go with the revenue function. R of x equals 29x. That's all we need for now. So from here, we will substitute this value into the x value. So we get R of 1273 equals 29 times 1273, and that is equal to $36,917, because it's the amount of money needed. So that is how to solve a business equation application system. And so see you next time.